Okay, we're back. I told them that I said if any of you put any strings about illegally finding PDFs online that I would remove it from the forum. He took that as very supportive. Is there anything you need to know? It's a quiz day. The quiz does not include anything about sets, which is basically all I'm going to lecture on today. It includes exactly what I told you on Friday it would be. It is a problem taking exactly from the homework. It's not even similar to the homework. It is the homework. And a thing involving truth tables that I already mentioned. Okay, let us start piecing through the slides. No one came to my office hours today, guys. I mean, I played with the forums during that time so I wouldn't feel like a big old shit. But, you know, if you need help, it's the earlier in the quarter you ask about it. Also, if you think you are especially having trouble, you should talk to me about it. You don't have to come to my office hours to do it. But if you are convinced that you in particular need special help, the earlier in the quarter I know that, the better. Okay? I realize that means I need to get you your quiz scores. Quiz 1 has been graded. You can pick it up with your TA. 400 quizzes is a lot of quizzes. Jackie. The TAs do not have office hours. Theoretically, you are able to go to at least one section or else you can't have enrolled for the class. You need to be able to go to your section to pick up your quizzes. If you need individual, oh, it's already taken. You have to sit somewhere strange, Kyle. Next time I'll try to save 3 seats in the front. I really use my MSI tutors. They're very important, and Kyle in particular has been with me forever. So yeah, if you can sit right there, Kyle, I'd be so happy. Kyle knows me and knows when I've gone off the rails. So, where was I? What was I talking about before I spotted Kyle? Oh, they do not have office hours because I have asked them to spend a significant amount of time responding to individual email and forum posts. In particular, that means that someone wants someone who's just coming in to come back and sit with them, I can tell.
Yes, I'm talking to you, Will.
Will wants to sit where he can see me. Don't you, Will? I showered today. I'm clean. Go ahead. You can sit. Look, she's nice. She has a hat. You would rather sit with him than her? Let's get real. And by the way, I love you too, whoever it is in the back of the room. Not the same? Well, in that case, I think you should sit in row 2 next week so I can shower you with individual love. In a clean way. I meant that in a clean way. So, the TAs, if you need something from the TAs that you cannot get out of section, they have guaranteed me that they will work with you. Okay? There's also me. There's the MSI tutors. There's additional unnamed help I can get you if you just, fess up and tell me that you are really feeling stupid. Maybe I shouldn't use that word, but I don't think any of you are stupid, but I know you guys think you're stupid. You just are trying to keep me from learning it. I'll never learn you're stupid. I will learn other things, like you've had really crappy math preparation, or that some of you I'll learn you're not working very hard. But if you come to me at the beginning of the quarter, I'm never going to think you're the people who aren't working very hard. Never, ever. We have TAs. They're marvelous people. I told them not to have office hours because I'm asking so much of them. You guys can ask of them also. We have a quiz today. We have a quiz on Friday. The quiz today does not have sets. The quiz on Friday will have sets. We have now 3 MSI tutors. Our 3rd tutor is going to send me a picture. And he's going to stand right over here and talk into the mic.
Hey guys, so just an update. My MSI sessions, I have.
Wait, come over here. We're going to write down. We're coming together. Okay, your MSI sections are?
The first one's going to be Friday 9:20 to 10:20 a.m. I have another one Tuesday 3:20 to 4:20.
I don't understand why it's like especially excited. It's writing when I'm up in the air. Okay, let's try that again.
So Friday 9:20 to 10:20.
Okay, I'm just going to put this.
Yeah, and then Tuesday 3:20 to 4:20. And then I'm working on getting another one up. Timings are a bit messed up right now, but I'll get that back to you guys by Wednesday.
They can't go to it tomorrow, right? The first one?
No, they can go to the Tuesday one.
Okay.
Tuesday tomorrow there will be a session at 3:20. So you guys can go.
So they can go.
It's at Crown 201. And to sign up, you guys can sign up at the ARC Center today until 6 p.m. After that, just send me an email and I'll let you know if you are in there. It's SVRUDDAR at UCSC.
I don't understand what's up with my pen today, but it starts writing when my pen is far from the glass. I don't know what's going on.
So yeah, you guys have to sign up at the ARC Center until 6 p.m. today, and yeah, SVRUDDAR at UCSC.edu.
Okay, can you read that one? I don't understand what's different about my pen today. I will investigate with the pen mavens and get back to you guys. Next, DRC guys, if you haven't sent me the stuff, please send it as soon as you can. We have like logical identities. Boy, do you care about those today. And we have normal forms. I'm going to do this fast because I've done this for more than one day, but we are going to real quick write down a function of P, Q, and R that has only 2 zeros, just so it'll be fast. Let's do 1, 1, 1, 1, 0, 1, 0, 1. Okay, so how do we write down the DNF for that? Well, the CNF for that, we write down the CNF by seeing where the 0 points are, and then writing down a formula to make sure that you can't, your assignment of variables isn't on that line of the truth table. Now, if you look at the top highlighted line, you are on that line of the truth table if P is true, Q is false, and R is false. Do you see that? Does everybody see that? So how do we make sure we're not on that line? Well, if Q and R are still false, but P is also false, you can't be on that line. So if P is false, or if Q is true, or if R is true, you can't be on that row of the truth table. That's 3 different ways you could violate being on that row of the truth table. Does everybody get that? Yeah. Okay, now all that does is keep you off the top highlighted line. If it shoves you down to the bottom highlighted line, you still lose. So you need to make sure you also simultaneously stay off of the bottom line of the truth, bottom highlighted line. The bottom highlighted line, you're on that line if P is true and Q is true and R is false. Does everybody see that? Okay, so if P is false, you cannot be on that line. Also, if Q is false, you cannot be on that line. Also, I hate my pen today, if R is true. And that's it. You have the CNF for that truth table. Okay? I'm not even going to entertain questions. We're going to move right on. Okay. A set is a collection of objects. We've been through a lot of this material too. I'm probably going to go fast. I make no apologies for not knowing the names of these little dudes. Okay. Sets almost always depend on a universe of discourse. What I'm saying here is that my universe of discourse are these specific Pokemon. Like Squirtle is not up there. And neither is Pikachu, And neither is Charizard. And I would be a rich woman if I had saved all my son's cards. But anyway, but I do not miss the fact that I had to talk to some other mother about how my kid was bad for taking the card that he took in the trade he made, consensual trade he made with somebody in kindergarten. What? Yeah, you go wild. So, in this slide, you can see that we're talking about the set that contains those Pokemon from this entire universe of discourse that contains all the pictures on the page. Curly braces with commas in between set elements is very common. So, in this particular set that I have here, I have the universe of discourse on the top, and then below that we have curly braces with the particular elements of Pokemon that are in set S. So that Blitzel is an element of S, but Zebstrika is not an element of S. And everybody should be comfortable with that notation. Now, two sets are the same, are equivalent, if they have the same guys in it. It doesn't matter that the order is different. It doesn't matter if sometimes you put Lillipup. You put Lillipup in there twice. No one cares. It does not change the set to put Lillipup in there 75 times. It's still the set, including all those dudes and Lillipup, no matter how many times you list it. The way you list that in math, and you guys need to become comfortable with why that math makes sense to you, and we're going to start talking about predicates, if not today, Wednesday. When I say, for all objects, if the object is an element of S, it must therefore also be an element of T. And if the object is an element of T, it must therefore also be an element of S. That's what that math down there below says. The upside down A is for all. Okay, there are some special sets that have names. Our version of natural numbers includes 0. Not all math books agree that the natural numbers include 0. By the way, by the time you take the quiz, you need to have your butt in an actual seat. I won't let you take it in that seat or by sitting on the ground. So find yourself a seat. Natural numbers, integers. Sometimes we put a superscript on it. So for example, man, I hate my thing today. Z plus is equal to the set of 1, 2, 3, dot, dot, dot. And you guys are smart enough to know that the ellipsis means that you keep counting. Now, R is real numbers. That includes stuff like pi and e and other things you can't do as rationals. Rationals, it's p over q, such that p is an integer and q is a member of z plus. When you say q is a member of z plus, you're saying, hey, we only need one negative number to get all of the positive and negative fractions. And we're also saying, no zeros in the denominator. Zeros in the denominator is bad. Okay, phi is the empty set. It is a set. Those of you who care about type checking, it's very important that phi is a set. Yes? We do not have a special alphabet for irrational numbers. You can say the reals minus the rationals. And I basically repeated the question by giving the answer in full English. Yes? Why would you do that? Q with a line on top. Not Q. No, you can't. No, sorry. I realize that makes sense to you, but you need to have a properly defined universe of discourse, and usually these are used to define the universe of discourse, so it doesn't make any sense. These guys don't make, the complement, the plus, whatever, all of those, for you to write rational bar would be irrational numbers, but only if you have somehow defined the universe of discourse. So let's not do that, okay? Not if you want your points on the quiz. You do whatever you want in the privacy of your own home, man. But don't ask for points for it. Okay, denoting sets, enumeration with ellipsis, set builder notation, that vertical bar. Man, in math, we love to use vertical bars for just tons of things. As a computer scientist, you need to get used to the idea of overload. Vertical bar is an overloaded term. In this notation with the curly brace, you can say S such that S is a subset of natural numbers. Okay, the vertical bar here means such that. It's obviously not the right bar of an absolute value, right? So, or any of the other things that vertical bars mean in math. There's ranges, cardinality is cool. Vertical bars, again, you put vertical bars around a set. It has to be something that's a set. We have a type check again here, guys. It means, for finite sets, it means the number of unique elements. For infinite sets, things are a little harder. For infinite sets, we have a certain number of sets that have an established cardinality. The natural number, that is our set, our established set, infinite set. To show that another number, another set is countably infinite, you come up with a one-to-one correspondence between the natural numbers, or a subset of the natural numbers, and the one you're trying to show. So countable versus uncountable. Here we have a subset of the natural numbers. It would work just as well if you had 0 on the front. And we have a one-to-one correspondence between the positive odd integers and a well-known popular subset of the natural numbers, also known as the positive integers, showing you that there is a one-to-one correspondence between these two sets, so they have the same cardinality. You understand why I'm so nervous about saying the same size, right? Because obviously, any 3-year-old could tell you that there's numbers on the top line that aren't in the bottom line, right? The thing is, there's just as many on the bottom as there are on the top, and all rational people should sit there and go, when you see that, right? It's weird. It's weird. Okay, subsets. Subsets, we're going to spend a lot of time talking about subsets. There's a difference between a subset and a proper subset. If you look at all possible, if you take a set, any set you like, set is S. It's interesting to look at all possible subsets of S. That's known as the power set of S. One possible subset of S is S. But S is not a proper subset of itself. Just like 3 is less than or equal to 3, but 3 is not less than 3, right? Does everybody understand that analogy? Okay, now, if there's a little bar, that means subset including the improper ones. But if you say S is a subset of T, God, I don't understand why my pen is just being detected all over the place. If you say S is a subset of T, that means there's at least one element of T that is not in S. Okay? Does that make sense? Proper subset versus subset. It's completely, by intuition, it's the same thing as saying that 3, God damn, this is annoying me. 3 is less than or equal to 3, but 3 is not less than 3. Okay? Appealing to your intuition. Cartesian products are where you take two sets and you make ordered pairs, all the possible combinations of taking one guy from column A and one guy from column B. And you guys use that all the time in terms of, suppose we were at a heteronormative dance in the 1950s and we didn't allow girls to dance with each other or boys to dance with each other, okay? And we lined all the boys up on one side of the room and all the girls up on the other. The Cartesian product of girls versus boys is all possible dance couples, right? Okay, and we do that for XY coordinates. We do that for assigning prizes to people in races. I mean, there's all sorts of stuff. Yes? The order of the pairs does not matter because it's a set. The order within the pair does matter. In fact, I was just realizing as I told you about the heteronormative dance party that I had to come up with an order, like always list the man first or always list the woman first. I'm not telling you which order it is, but for an ordered pair, to be an ordered pair, you have to know when you look at the first guy. Okay, so the first pair is Chris and Pat. Did we list women first or men? Because I don't know, right? Okay, but if it's, I don't know, Muhammad and Maria, I'm pretty sure, right? Are there any women named Muhammad, do you think? Because I'm thinking no. In France, there are men named Maria. So I know because I dated one. Anyway. Well, it's Marie, not Maria, but you get the idea. And he was not at all feminine, I got to tell you. Very disappointing. Anyway, the power set of this set, P, is the set of all possible subsets. This will 100% for certain sure be on your quiz on Friday. Not today, but on Friday. Power sets are going to come up, okay? Because power sets are a very important concept. For example, the power set of 1, 2, 3 would include all of the subsets of S of size 0. Oh, I hate this. All of the subsets of S of size 1. All of the subsets of size S with 2. I hope you can read this. Say that again? Should I do that in the middle of class? Can you walk up after class and talk to me about it? Is that okay? Whoever that was? Okay. And then, oh, this is good. How many subsets have I got there? 7. There's 3 elements of S. There should be 2 to the third subsets of S. I've got 7. Which one am I missing? I'll be there right. The one with all 3 of them. And it doesn't matter what order I put them in, right? Never matters what order you put things in a set. And did you have a question?
Yeah, on the third line,
1,3. I realized I don't know what happened. I don't know why this was fine on Friday. There, is that better? But I feel like I'm coming in and just attacking with my paint, you know? I didn't normally think about my application technique for my pen before. That person and then the person in the middle. Yes?
I'm not sure if my memory stays from last time, but this looks really similar to Cartesian.
We're not Cartesianing. We're looking at subsets. We're only looking at that set right there, 1, 2, 3. And you want me to cross 1, 2, 3 with 1, 2, 3?
No.
I could.
No, it's just my memory.
I'm like, I'll cross anything. I'm so happy this is gone. Yes? I'm sorry, I can't hear you.
The first one is an empty set, so can I just write a fee there?
Yeah, I could write a fee. We'll see if I can write a fee. I feel like I'm pecking it as a bird when I get it, Fee can be vertical and it can be slanted. We're talking, do you know how, fonts, right? Do you want to talk about whether they're serif or non-serif or, it's a fee. I goddamn guarantee you it's a fee. Somebody asked me today, I swear a lot in class, am I religious? I was raised religious, and that's why I use the Lord's name in vain, but he ain't my Lord no more. You wouldn't think less of me for not believing in God, would you? Question is, which God do I not believe in? Set theoretic operations. We are going to be talking about union, intersection, difference, complement, and symmetric difference. I think Venn diagrams are worth very little in life, other than understanding dumbed-down illustrations in Time magazine. But I do think that they are useful for acquiring intuition at the very beginning of understanding about sets. You have a universe of discourse U, you have set A, you have set B. A union B are all elements that are members of either A or B, including some that are in both. A intersect B. Now, what's really important here, what you guys need more than anything else, is the math at the top, not the Venn diagram. The Venn diagram happens to be on the sheet where I'm showing you the math that is the definition of union. So these are not Venn diagram illustrations. These are math illustrations that have Venn diagrams on there for intuition. Okay, the intersection. A intersect B is just a little wedgie. It's the set of all x such that x is an element of A and x is an element of B. That's what's important. The fact that it also makes a cute yellow wedgie is just a bonus. Okay, it's possible to talk about the union of two things that we're not touching before, at which point I'm never going to use this in this class. I just want you to have seen the terminology. Union sign with a dot over it means disjoint union. Means A and B are known to have no elements in common. I still want to talk about their union even though they don't kiss in the Venn diagram. Okay? Set difference. Order really makes a difference. A union B is the same as B union A. But A set difference B is completely different than B set difference A. For A set difference B, you take all the elements of A and then you remove any that are also in B. So the guys that are just in B, nothing exciting happens with them at all. So A set difference B is that weird little moon eclipse doodle. And B set difference A would be the one that's not colored in on the other side. That's like a mirror image of it. Everybody get it? Okay, but the most important thing is that A set difference B is the set of all x such that x is an element of A and x is not an element of B. That's the thing you need. Okay, set complement are all the members of the universe that aren't in the set. That's why our friend in the 20th row, no, I'm not answering that question. We're going to keep going. It's only possible with a defined universe. So we're not going to be sloppy, even though we are tempted to. I'm going to be sloppy, but I'm going to try to. Set operators are exceedingly similar to logic operators. They come in exactly the same number and variety. And if you care, you can look up online how to take any theorem in set theory and transform it formally into a theory in propositional logic, and vice versa. This does not work for axiomatic set theory. Axiomatic set theory I'm about to talk about in just a minute, and I'll tell you why it is ugly. Bit string representation of the sets. This is for the programmer in U. Basically, you establish, suppose you have the letters of the English alphabet, A, B, C, and so on. And you assign that 1 means A, 2 means B, C means 3. And then now you just have a 26-bit array. And I can't head off 26, but let's just pretend there's 26 there. So now if you put 1, 0, 1, that means, hey, I want A in there and C in there, but B's not in there. So you just have a one-to-one correspondence between a binary array and some set. And we use that kind of stuff all the time. Now we can use bitwise AND to do union, bitwise AND to do intersect, bitwise OR to do union, bitwise XOR to do symmetric difference, and so on and so on. Set membership tables are completely analogous to truth tables. So here, each row corresponds to an element, and then the columns are for sets. So for A, we're saying if X is not an element of A, then we put a 0. If X is not an element of A, then X is an element of A bar. If X is an element of A, then you put a 1. If X is an element of A, then X is not an element of A means that you put a 0. So what that means is you can go through and look at set theoretic operators. Basically, this is exactly the same as a truth table. And I'm not saying that as intuition. I'm saying that set membership tables are truth tables for sets. They just flat out are. So here, intersection says only items that are members of both A and B are members of A intersect B. The math for that, just like on the Venn diagram page. Set theoretic for union. The math for that, just exactly like on the Venn diagram page. Is my TA here? Oh, hi, Victor. Come down here with me, will you? Same thing. Same stuff. You can prove things about set identities using set membership tables. I want you to know, this is not important today, it will be important for Friday, Venn diagrams prove nothing. They're a picture to help you with your intuition. If I ask you to prove something and you give me a Venn diagram, you won't get credit. You use a set membership table or you use logic identities, and I'm good. There is such a thing as generalized union and intersection. We're going to talk about summations and products. This is very similar to that. This says for all sets with the subscript I, union them together. So if you have A sub 1, A sub 2, A sub 3, A sub 4, we're going to union them all together. Or intersect, A sub 1, A sub 2, A sub 3, we're going to intersect them all. So this guy would be all the elements that occur in any of the sets, and this guy would be only the elements that occur in all the sets. We're going to go just a few more minutes. You have, where's the quizzes? Yeah. Okay, and you, I don't care. Why don't you start passing them out, and I'm going to keep lecturing. Okay. I wanted to say something important here. I wanted to introduce you to Russell's paradox. This is why we have axiomatic set theory, because Russell's paradox should blow your mind. Okay. The set R consists of all sets that are not members of themselves. Okay, now you may never have thought of making a set an element of itself, but you're computer scientists or something similar now, and think about recursion. So, if R consists of all sets that are not members of themselves, what set is R in? Another way to say this is to use ontological. Try to keep the, if you want to take the quiz, get your butt in a seat and try to keep it reasonably quiet so that I can tell you guys about ontological. It's a word that means refers to itself. For example, English is an English word. French is not an English word. I mean, it's not a French word. But français is a French word. Words that apply to themselves. The question is, in which camp do you put heterological? Another way to put it is, you're on a remote desert island where only males shave their faces, and the barber shaves, the male barber shaves all men who don't shave themselves. Who shaves the barber? Okay? Another way to put this is lather, rinse, repeat. Another way to put this is a two-sided piece of paper that says see other side, see other side, see other side, see other side. It's not stable ever. So spend some time thinking about Russell's paradox. Now, the last thing I want to say is, first of all, don't turn your quiz paper over yet. You should be staring at the identities. Okay, remember guys, this is something that's important. When you're done, they need more quizzes than that, I can tell. Don't go out this door. Oh, you can go out that door. Peeing can happen out that door too. Okay, when you're done with the quiz, please go out any of those three doors. Do not go out this door. I'm going to shut these doors. You're not in my class, are you? You're not in my class, are you? Okay. But you'll be quiet for them? Oh, yeah. Okay. Okay, are you guys good?